Hi, my name is Wojtek. I'm on the Android developer relations team, working for Android, and mostly working on Kotlin, which is great. Seems like I'm at the right conference. And today I want to talk a little bit about APIs in general, and the APIs that we have in Android Jetpack. But before we get there, let's talk a little bit about how Android development looks these days. So if you've been following Android Dev Summit, which happened just 2 months ago, we announced our thinking about what modern Android development is. And if you looked at the talks, at the schedule, if you listened to some of them, you will notice that most of them mention Jetpack, which is our new set of, newish set of libraries for Android development. And Kotlin was present throughout every presentation. All the code on the slides, most of the new libraries, most of the new stuff mentions Kotlin. Now, of course, there's more things coming, like Jetpack Compose, which you might learn about today or yesterday at this conference. Of course, you need a modern Android IDE, which you will use every day for development. And there's, of course, Android Studio based on the great IntelliJ IDEA platform. And also, we have modern Android app distribution in play using app bundles and dynamic delivery to make sure that you deliver the most optimized experience to your users. But as you can see, I will focus today on the first two parts, which is Jetpack and Kotlin, which will be probably the primary surface, like API surface, that you will be using when developing apps for Android. And in fact, since we announced Kotlin, we've seen tremendous uptake in developers using Kotlin for their apps. You might have heard yesterday at the keynote that almost 60% of top Android apps used by millions and millions of people use Kotlin somewhere in their code base. And even Jetpack Compose, the new UI toolkit that we're working on, the future of Android UI development, is being built with Kotlin at its core. So it uses a custom Kotlin compiler plugin, and it's made to work with many of the language features in Kotlin that you know and love. But let's take a step back and think about how it all started. So in 2017, some of you may have already been using Kotlin, maybe on other platforms, maybe even on Android. But at Google I/O that year, we announced for the first time that we're going to support Kotlin as a first-class supported language on Android. And to put that in context, think about when Android hit the market for the first time. It took almost 10 years since we released the first Android SDK, enabling you to make your apps, create your apps in the Java programming language. And then a year later, in 2009, the NDK was released, which introduced C and C++ for creating native libraries to be used on Android apps. Almost 10 years have passed since then, until we actually added a new language to Android. So in addition to Java, C, C++, for the first time, you could use Kotlin to create apps for Android. And that was a huge step. At the same time, developers were already using it. We were kind of meeting the developers where they are, where they wanted to be. Kotlin is a modern language, and in a way, it made development for Android fresh, new again, more fun, if you will. But at the same time, it's not as easy as saying we're going to support a language and boom, it's done. It's been a process. And even now, I don't know if it'll ever be finished, but we'll talk about how we progressed since then and what's available to you now as developers. So at the same time, when we released Kotlin, when we announced it as a supported language, when we said, look, you can make apps in Kotlin, we will try not to break it. Now we bundled a plugin in Android Studio. Everything's good. We also released, for the first time, something called Android KTX. And of course, like I just said, the Android platform didn't change overnight. It was built over the past 10 years. It had all the Java-based APIs. And that's not going to change soon. They're baked into the system. We have to keep supporting them, which is good. The apps will be backwards compatible. At the same time, they were not always great for you as Kotlin developers to be using them from Kotlin. And Android KTX was created to kind of paper over those APIs, those existing APIs. And Kotlin was actually a great fit for that. Like in this simple example, like maybe shared preferences is not the best API there is, but I had to include this snippet because this one short function definition uses already so many of the Kotlin language features that actually let us build libraries that extend, that fix the functionality of the Java-based APIs that were there. So here in this example, of course, we use an extension function on a type that's defined in the platform itself. There's no other way we could actually change that type and make it more Kotlin-friendly because it's baked into the system. It's on the user's devices. There's no way we can change it. However, with extension functions, we can easily add a new function called edit, and then use all the nice things that Kotlin gives us, like default arguments, so that we can provide sensible, sane defaults to guide users towards the right outcome. Like in this example, shared preferences has two methods, commit and apply. And you really have to read into the documentation to know what the difference is, which one to use. And really, there's usually no reason you should be using commit instead of apply. So we just bake it right into the method, the function definition here. And of course, we have a lint check in the IDE to actually remind you to call that apply after you added your shared preferences. What we could do in Kotlin instead of returning some kind of object that you have to remember to call apply on, you could pass in a lambda and with a set of actions you want to do on those shared preferences. And after all that, this function will take care of calling apply for you. So even in this small, simple one-function example, we already see some of the benefits of having a Kotlin version, a Kotlin API to your existing Java libraries. But really, all of that, all of what I just showed, these are just syntactic changes, right? It's just a different syntax. It doesn't make shared preferences more powerful. It doesn't change what the API does. It just makes use of existing language features to let you access that API in a better and a nicer way, sometimes safer even, thanks to nullability, for example. So what really is a KTX library? The thing is, it's just a name. It's just a name that we came up with for Kotlin extensions libraries for Android APIs. It's not a new technology. It's not something that you have to learn. If you learn Kotlin, you can start building your own. And we're going to talk about it in a little bit. Now, coming back to our modern Android development for a bit, in 2018, so a year after we added Kotlin to Android, we announced a project called Android Jetpack. Now, even before, we already started moving to a model where instead of just giving you the framework and giving you the language, the IDE, and saying, go and make apps, like here are the framework APIs, you can do whatever you want with them. We released a set of architecture components that would help you build your apps faster, that would make the APIs more accessible, that would build on top of the functionality given to you by the framework. And in 2018, we took those first architecture components libraries and incorporated them into a larger project called Jetpack. So a lot more libraries, a lot more functionality, and a lot more KTX. So we expanded the original Android KTX, which was the core library, which only touched the framework APIs, into a set of libraries that let you work with Jetpack in the Kotlin way. Now, many of you have told us that actually Jetpack grew so much that it's really difficult to find out what those libraries are and where you're supposed to use KTX extensions. So I'm happy to announce that just a few days ago, we put up a new page on DAC listing all of our existing KTX extensions. So if you go to developer android.com/kotlin/KTX, there's an overview page where you can learn a little bit about those APIs. And then if you click on a list of KTX extensions, you have a whole long page with all the extensions that you can possibly find in Android X. Now, we know that's still not ideal. You would like to do that straight in the IDE and have some kind of suggestion on where you can use KTX libraries. We're exploring that, but nothing to announce yet, unfortunately. OK, so what are some of the examples of why you would even want to use KTX versions of a Jetpack library? So I'm going to go through a few examples just to tell you why even bother using an artifact, a Maven artifact for those libraries that gives you Kotlin extensions. So for Room, for example, for your persistence layer, for your database, of course, since it reads from disk, it writes to disk, it does async operations, What we would love to have is to enable it with the power of coroutines. And in fact, for some time now, you could use suspend functions to get data back from Room. So this eliminates callbacks, makes sure you don't block your main thread. And now, recently in the newest versions, we announced support for Flow, so you can even get streaming results back from the database. Now, for Work Manager, this is a library that it's not necessarily about running something on a background thread, which is normally what we think of when we think about async operations that we want to run as a coroutine. Now, Work Manager is a library for doing background tasks in a sense of tasks that run in the background when the user is not interacting with your app necessarily. So these are periodic operations that happen, for example, every day at night when the phone is on the charger and you need to sync some data with the network. The thing about these tasks is the system tightly regulates when and how long they can run. If, for example, you define your task as, hey, this job needs network. I need to pull some data from the internet in order to save them to disk for caching. If the user disconnects from Wi-Fi, the system will send a signal to your job, hey, you need to cancel. You no longer have network. And now this brings me to the second property of coroutines that are really important on Android and on any platform, really, which is cancellation. So now using this new coroutine worker for Work Manager, whatever work you're doing, if you're calling any suspend function, if you're creating any coroutines from there, if that gets canceled by the system, you almost get it for free, right? All of that cancellation will get propagated into the suspend function you're calling, and you will end your work in a timely manner. So this is great. Now, ViewModel. ViewModel I treated as really as the base for our coroutine support, since probably if you have your UI, like an activity or a fragment, in the model that Jetpack offers, you will have a view model backing the data and the operations for that UI. And normally that's where you would start reading something from your database or other layer like a repository. That's where data coming from the network would come to get processed to be exposed to your UI. And also, all those operations, again, are asynchronous. And of course, as we know, every coroutine has to run in a scope. So we now offer a ViewModel scope so you can safely run those operations, and they will be canceled if the user leaves the current screen where the ViewModel operates, which is great. So we now get automatic cleanup. We don't need to keep track of that work that is happening in all those coroutines. We don't leak memory. We don't leak operations. We save the user's battery and performance of the device. And finally, you probably heard about live data, which was normally used to bind from those views that I just mentioned, from the activities, from the fragments, to the live data exposed by the view model, so that you could observe data coming in from the view model and update your UIs. And of course, now with Flow, you might think, many of you might think about replacing live data with Flow. This is a completely valid approach with some caveats. If you need to understand exactly when and how collection happens from the UI. However, if you don't want to replace all your current architecture, if you still want to be binding to a live data from your UI, we now have adapters from Flow to live data and vice versa. And we even have a new live data builders that actually let you run suspend functions and create that live data using suspend functions in your lower layers of your app. And if you're interested in how an architecture like that could look like, we recently open sourced our Android Dev Summit app. So this is our first big sample that uses an architecture based around using Flow in the lower layers of the application and exposing live data back into the UI. So that's now open source. We have an article on our Android developers Medium page that explains some of the lessons learned and caveats of using this kind of architecture. So please check it out. Okay, but since I said, KTX is not something proprietary, it's not a technology that we made, it's just a set of extensions that you build for an existing API. The fun part is you can build your own. Since, as Android developers, we built up a lot of libraries, a lot of APIs over the years that you will probably use in your apps. And now, as you start slowly converting your code bases to Kotlin, maybe you would like to have a nicer way of calling them. And so recently I had a chance at Google to build one of these KTX extension libraries called Playcore KTX. Now, Playcore is not actually part of Jetpack, which means, Jetpack is not the only place where we're investing in Kotlin. In fact, we would like all of our libraries to be accessible to Kotlin developers. And so Playcore KTX is a set of APIs that you would use for in-app updates. So if you want to trigger updates from inside of your application, or for downloading modules dynamically to your application from the Play Store. And so inherently, since these APIs communicate with Play Store on the device, that goes through RPC. And it means it just has a lot of async calls. So we're going to talk about it a little bit later. But I'm going to focus first on a few basics. So like I said, the base of what you do when you implement something like a KTX library will be working with extension functions. And an extension function is a little bit different than a normal member function in a class. So you probably know that if you define an extension function as a top level in a file, let's say in a file.kt, that actually gets compiled to that JVM bytecode and to Dalvik, of course, as a static function. And there's a class created for that file, usually named after the file itself. So that means that extension functions don't actually modify classes, right? It's not a bytecode transformation. We're not inserting anything inside the class. It's just a static function that exists completely outside of the class. Well, one interesting thing about that is you can't really access any private fields or methods inside that class. It's even more interesting with extension properties. Now, again, for normal member properties, what they do is they generate a field inside of the class. And that field can be initialized with some data. It can store some data. Extension properties, on the other hand, behave a little bit more like extension functions. That means you can't have a property that is initialized to a value. It always has to be a getter in case of read-only values. With vars, of course, you would have a set function as well. And that gets compiled down to exactly the same thing as an extension functions. So really, whenever in the rest of this presentation, when I say extension function, it also means that extension properties behave the same way. And so one interesting, so no backing fields for extension properties, only computed values. Now, if we go back one slide, you can see that there's an interesting thing that happens with the base type that the extension is put on. The base type actually gets used as the first argument to the static function. And that has really huge consequences for something called static dispatch. I don't know if you're familiar with that term. I came up with a puzzler that maybe some of you probably know, but I'm hoping some of you will learn a new thing. So what is static dispatch? How does it work? Why doesn't it work as we expect it to for regular functions? It works differently for extension functions. So let's say we have a class called super, and then we have a class that is not super, and extending from that class. And so we have two extension functions, right? We ask the super class, who am I? It says, I'm super. Now the not class says, I'm not. So what if we have someone who is not a super? Who is he? So how many of you think it's going to print out, I'm super? I see a few hands. How many of you think it's going to print out, I'm not? A lot more. Well, actually, because of static dispatch, this will print out, I'm super. And this is only because I've casted it as super here. Now, if these were normal overridden methods on a class hierarchy, it would have printed out, I'm not. However, with static dispatch, which is what is happening here, which method is called in here is decided at compile time. At compile time, I've said that this variable, this value, is of type super. It's the inferred type that would be put here, right? And because it's inferred type, it's super, when I call this method, it goes here, to super. Now, normal methods in a class hierarchy have virtual dispatch at runtime. And at runtime, the runtime would know that it's actually an object of class not. So it would dispatch the method to that object. So this is static dispatch. What's interesting about this is you have to be very careful to not try to model these class-subclass relationships when doing extension methods. While you can do something like I just showed, you have the risk of the user of your library just calling the wrong thing and not being aware of that. So yeah, extension functions and properties have static dispatch on the receiver. Now there's one very interesting thing that I learned about Kotlin metadata when working on the Playcore library. So now that you have some extension functions written for your library, if you go into Android Studio or IntelliJ and you pull up that Kotlin bytecode pane, you will notice that other than your typical bytecode, the contents of your implementations of your methods, you also have this Kotlin metadata annotation, and also a new file is generated for your module with metadata again. Now, this is not human readable. This is just something that gets added to your classes, to your functions, to your module. And some of the information encoded in there actually tells the compiler what our extension functions, how our extension functions are defined. So I've told you before, they get compiled down to regular static methods on a class. And yes, that's how they look in the bytecode. But in order to be recognized as the compiler, as extension functions, it has to have access to this metadata. Now, for regular Android apps, many times if you go on Stack Overflow and you look at answers to some questions about these Kotlin modules, you might read that, oh, it's completely safe to remove for your application. It's only used by reflection. And that's true. Many times if you distribute your application to the Play Store, maybe if you remove the metadata, if you're not using reflection, everything should work. However, if you're creating a KTX library, if you're distributing it as an AAR for other developers to use, you must leave that metadata alone, and you must leave it in the file itself, or the developers who are trying to consume the extensions that you're creating will not be able to access them. Now, normally, it's probably not something you should be worried about. However, in my case, I had to do some transformations on the bytecode produced by my build system. So in a way, when I was building the Playcore library, I had to depend on the old support library and then transform it to use the Android X namespace. And what I found was every method that I wrote, every extension functions that I wrote that used Android X fragments broke. It was no longer accessible. So if you're doing any kind of post-processing on the bytecode, if you don't also process that metadata, and there are libraries to do that, you will break this connection between an extension function and the actual types that they're supposed to work on. OK, so don't mess with Kotlin metadata. It must be present. It must match the classes that you were originally defining them on. Now, when trying to kind of fix up the API of the library I was working with a little bit, I found that the original developers didn't follow the getter-setter convention of having get field, set field, or property naming. So instead, what they had was, they had these functions that were just the name of the property I want to get. And of course, in Kotlin, I would love to get that nice property syntax. What I found was that, that there wasn't a way for me to actually fix that. It was either a choice of adding a property and still seeing the original method in there, or not having it at all. So for the future, if you're creating a Java library and you are thinking of then people will be using it in Kotlin, make sure you think about proper naming in the first place. And there's actually an inspection in Android Studio that is disabled by default. So if you go into inspections, you enable this interoperability one. This will tell you if your API surface is Kotlin friendly. So if you're library developers, if you're want to think about the future about exposing your API in Kotlin, enable that, check your library. It'll tell you a few interesting things about nullability, using lambdas, and also the naming of the properties. So yeah, you can't fix everything with KTX. It's nice to have the proper code in the first place in the Java version of the library. And the last thing I learned was when I tried to generate documentation for my library. So Playcore KTX and the original Playcore library are unfortunately closed source. And normally the way you distribute documentation with your libraries, if you release them on a Maven repository, for example, is first of all, you build your main artifact. This contains your classes. This is consumed, of course, by Java or Kotlin compiler when you build your code. But then automatically the IDE tries to download and attach one of two artifacts. So either sources, where if you have that present, if you distribute your sources together with your library, both in Java and in Kotlin, you will get this quick help documentation in Android Studio. However, if you only generate JavaDoc, which are HTML files containing all the JavaDoc read from your classes, that only works in Java. And unfortunately, since my library wasn't open source, there was no way for me to generate this. Now, there is one trick that you can do, and that's what I did for the Java version of the library. If you have your sources, if you have your JavaDocs on there, if you have a tool that could process all your sources and basically rip out the function bodies, just leave a stub in there, you could distribute that as your sources jar, and then the IDE will be able to read the documentation. However, I didn't find a tool so far that would let me do that for my Kotlin sources. So I'm hoping maybe Docker, maybe a tool called Metalava in the future will provide me with that capability. As it stands for now, unfortunately, the library is distributed without JavaDocs in the IDE. Cool. OK, so let's talk about async APIs. I mentioned that PlayCore is inherently asynchronous. And so are many other APIs on Android, Google Play Services, many of the networking APIs that you might use, anything regarding using disk operations. All of these will be async APIs. That's because we never want to block the main thread and freeze the UI. And when thinking about async operations, usually we distinguish two different types of calls. One-shot requests, which you fire once, wait for some time, and you get a result, and you're done, or a failure. And then we're going to talk about streaming multiple results in a bit. So let's talk about how you can turn these callbacks, these one-shot callbacks, into a Kotlin-friendly API. So let's take this, one of the many methods in the PlayCore library. The way they're implemented, they go off to a background thread, they do their work, instead returning you a task. So they're a task-based API. And on that task, you immediately set a listener. So a success listener and a failure listener. In case of success, you finally get your object that you actually want to use inside of it. How do you turn that into a suspending function that we can use in a coroutine in Kotlin? So first of all, there's this low-level coroutine building block called suspend cancelable coroutine. And that's really what you want to use for one-shot requests. So you define an extension function on my app update manager that I will be using. In there, I do what I would normally do for the async API, for the callback-based API. So I get a task. It starts working in the background. And at some point, I will get a result. So if it's successful, I get a result. And inside of that suspend cancelable coroutine block, you have something called a continuation. I shortened it just for the slides, but yeah, it's a continuation. On that continuation object, whenever you want to return back a result, so your suspending function will actually return that result back to the caller, you call resume. Now, of course, that API can also fail. If for whatever reason it can't get the necessary information from Play Store, it will throw a failure. And so I can attach a failure listener, and there's another function, resume with exception. And one more thing I want to mention, even though in the case of the task-based API, it's not used, there's also a way for you to be notified by the coroutine if you should cancel. So if the coroutine is canceled before you've had a chance to actually return a success or failure, you can set a cancellation handler. And in there, inside of it, you can, let's say, cancel your network call. In the case of this API, there's nothing to cancel because the task will just complete and we can ignore the result. However, it's useful if you have a nested, let's say, several nested operations and you want to cancel them in the middle of this suspending function. OK, so now that we have our suspending function built using suspend cancelable coroutine, we can use something, again, like a view model scope, launch our coroutine, and have a nice sequential way of working with the results from this API. So that's how we built a suspending function for an existing callback-based API. Now, if you want to learn more about suspend cancelable coroutine, Chris Baines, I think, just released a new article, again, on our Android developers page, where you can learn about creating suspending functions for many of the view operations that you would do, so animations and other stuff. So it expands a little bit upon what I just said. So it's not just about network operations. It's literally any callback-based API that can be canceled in the middle. OK, so let's get back to turning our async APIs into Kotlin versions and talk about streaming requests. So by streaming, I mean usually you have an API where the first thing you do is you define an object that's usually called a callback or a listener. And then you request some kind of updates from the API. So here, we're leaving the Playcore API for a bit. And let's talk about location. So if you access something like the Fuse location provider on Android, it works exactly like this. You set a callback. You request location updates. You can get a failure or not. If not, at some point, your location result callback will be called. And as long as you're observing that, as long as you're subscribed to getting those updates, as the user moves around, you will get GPS coordinates from where they are delivered to that method many times, indefinitely, if you never unsubscribe. And so you, of course, have to remember to, when you're done with it, to remove the location updates. And this is a very verbose, very error-prone API, but it's just the normal way that we used to do APIs on Java-based library, right? What we're going to do is we're going to wrap the whole thing into another low-level building block for this time for Flow. So this is a function from a family of functions called Flow builders, and this callback flow is a builder that does precisely what it's named after, so turning callback-based APIs that return multiple results into a flow that you can consume from your view model. And so we're wrapping it in a callback flow, and inside of that, you don't get a continuation, but you get a producer scope. And there's a couple of interesting functions on that producer scope that we'll use to make sure that we're doing the right thing while encapsulating all of that boilerplate so that the user of your library never has to deal with it. First of all, whenever we get results in our callback, we use the offer function to kind of put that result into the flow and send it away to be consumed from the other side. Then you have to always remember to close the flow at some point. So here, in case of failure, we use close and pass in an exception. Now, you can also use close to just finish the flow without passing in any exception. So that means it just completed. In this case, the location callback never really finishes. It's sending an indefinite stream of location updates. So we're not using the close version. However, at some point, the updates needs to stop. So whenever the user navigates away from your screen, the view model scope will cancel this flow collection. And the last thing you always need to call on callback flow is this await close function. And in there, you can actually pass in a block that will be executed whenever this coroutine is canceled or this flow is completed. So it not only works for exceptions, but also for completing the flow successfully. And here, you can put any cleanup that you need to do. And see, that's it. Now, all of that logic is encapsulated into one nice function that we can call from our application code and simply wait for the flow to deliver locations to us. Now, there's one more way you can actually send these locations or send these updates into the flow. So what I used was offer. And the difference is between offer and send, which is also available on the producer scope, is that offer can drop some of the updates, can drop the results and never deliver them. So for example, if you're using a buffer for the channel that is backing that flow, and that buffer is full, there's no way to put any more updates into that buffer. If you use offer, this method will simply return false, and you will lose this result. The case of location, that's probably fine for me because I can always get the next one if my flow connection resumes. But for some APIs, you might want to use the send version, which is actually a suspending function. And because it's a suspending function, whenever the buffer is full, it will suspend until it can actually put more results into that buffer, into your flow. And in a way, this is how Flow implements back pressure. So if you care about that, you can use this version. Now, it's a little bit more complicated, since you could, for example, use something like a conflated flow, and then it will always accept new results. So it really depends on the API and on the way that the user will consume that API. I just want to give you an overview of the choices that are available here. OK, so going back to my PlayCore example, there's one more thing I learned about, interesting thing I learned about Kotlin supporting the IDE. So the original API, when it delivers results to the user about the progress of your application update, it has this set of intdefs. It doesn't use enums. It uses ints. And then normally what you do from your code is you write along a when, and you try to handle all of these results. So let's say you're updating your app, and at some point the update is pending, that is probably downloading, at some point it's downloaded, installed, and so on and so on. The thing about indefs is they serve a purpose if you're writing Java code, if you don't want to use enums for some reason. But when I tried to write an exhaustive when over them in Kotlin, I found that Android Studio didn't actually suggest all the options to me. And I also thought, well, do we really need all these states? I told you before that you can take the opportunity when writing something like a KTX library to make sure that the user is doing the right thing, that you're guiding the user through your API to make the right choices, to make it easier for them to handle all states. And so in this case, I decided to actually change it a little bit and exposed sealed types that encapsulate some of these intermediate steps and make the API surface a little bit nicer, a little bit better for the user. And now if they collect the flow that is emitting installation updates, they can simply do an exhaustive when over these 4 options. And because they're sealed classes, I can even put more data in them, such as how many bytes have been transferred and so on. So to sum up a little bit about async APIs and turning them into Kotlin versions. Use suspend functions for one-off requests. Use flow for something where you need to return multiple results. Always remember to handle all completed states and or all failure states. So remember when we wrote a suspend cancelable coroutine, I handled both the resume and the resume with exception function. Otherwise, you could just leave your coroutine hanging. It would not be doing any work, but would still be present somewhere until the scope is canceled. Same with flow. Always remember to handle, whenever you're not going to send any more updates, close the flow, close the channel, release the resources. Always remember to clean up. That was the await close at the end of my flow. Since I registered a listener every time someone creates that flow, someone starts collecting that flow, I need to remember to unregister it at the end and not burden the developer consuming that API with all this unnecessary boilerplate. Expose main safe interfaces. By that I mean I didn't have to do anything special because all of these functions that I presented today, so the location, the PlayCore API, they all have their callbacks back on the main thread. So I didn't have to do anything. And now if you call my suspending function, if you start collecting my flow from the main thread in the UI, it's all fine. However, if you have other APIs and you're turning them into suspend function, it would be nice if you do that thread backgrounding for the user and make your suspend functions and flow safe to simply call from something like a view model scope with the main dispatcher. And yeah, and sealed classes, I just talked about it. They're a great fit for if you have to return something like multiple different states or result types from a flow. They work great, especially with when. OK, so going back a little bit to our history of modern Android development. If you've been following it closely, you might have heard that we announced at this I/O this year so half a year ago, that Android is becoming more and more Kotlin first. Now, I didn't say it became Kotlin first or that the job is done and now we're not accepting Java code. I don't think that's ever going to happen. However, if you've seen the progression, whatever we're doing with the APIs, with the platform, we want to make it as best for Kotlin developers as possible. And in fact, looking a little bit into the future, we're going to see more and more of these Kotlin-friendly APIs coming both in Jetpack and other Google libraries. And we're already seeing it also in the third-party library ecosystem. So one mentioned, Retrofit, the library probably most used for network connections among Android developers, already exposes suspend version of their functions. And we would like to see more of that, libraries either exposing Kotlin versions of their APIs. We might also even see first 100% Kotlin libraries. That's already happening in the ecosystem. We might even see some from us, from Google. There might be Jetpack libraries that are written in Kotlin and then expose a Java-friendly API. So maybe if I'm here on this stage next year, I will be telling you how to turn a Kotlin API, a coroutine-based API that has coroutines at its core, how to expose that to be runnable from Java code. And then at Android Dev Summit, we announced a new version of Android Studio 4.0. And for the first time, we have experimental support for Kotlin script in build Gradle files. Now, it's still a work in progress, but we aim to have it completed either in 4.0 or 4.1. So you'll be able to use Kotlin across not only your application code, but also your build scripts. And apart from Jetpack, it takes a lot of work, a lot of teams to work together to really make sure that support for Kotlin and Android is great. And so our compiler engineers, the Android Studio team, they're working really closely with JetBrains to make sure that the compiler is great, that the build speeds are getting faster. We have specific await optimizations to make your Kotlin code run fast on Android so that you don't lose performance or don't sacrifice application size if you use something like Lambdas or other constructs from Kotlin. So yeah, this is it. I'm hoping that you will create a lot of great libraries with Kotlin in mind and that you will enjoy using Kotlin on Android. And I will be at the Android Jetpack booth for a while. So if you have any questions about either the Jetpack APIs and how to use them, or how to transform your existing APIs to be Kotlin friendly, I'm there. Thank you.